Assalamualaikum warahmatullahi wabarakatuh. My name is Aqeela Balqis, binti Asmira, and I am from group 17. In this video, we will look at the overview of the details predictables and also the basic of predictables. There were more than one person behind the discovery of predictables, about 6 person behind it. The first one is the Antoine Lavoisier. He classified the elements according to the metals, non-metals, and earth. Second one is Johann Dobereiner. He discovered the law of troids. The third one, Alexander. He made the three-dimensional arrangement of known elements. The fourth one is John Newland. He discovered the law of octave. The fifth one is Julius Lothar-Meyer. He was the first to recognize the predict trends in the properties of element. And the last one, the predictables that we use until now, is made by Dmitri Mendeleev. He discovered the predictables or predict system with element arrangement in increasing order of their atomic masses. In this slide shows that the basic elements in the predictables. As we can see at the top left corner, there are atomic number of carbon, which is 6. And at the bottom, there are atomic mass of carbon, which is 12. And the C symbols means that carbon. Before we learn more about the predictables, let me introduce you the fact that atomic number is more reliable than the atomic mass. This is because of every element has a fixed atomic number and it increased by the value of 1. So this is the reason why we use atomic number instead of atomic mass. For example, in hydrogen we have 1 atomic number and in helium we have 2 atomic numbers. The vertical column from top to the bottom are known as group. There were about 18 groups in the predictables, while the horizontal rows from the left to the right is called as periods. There are 7 periods in predictables. In predictable, each group has their own characteristic. For example, in group 1 is alkaline metals, group 2 is alkaline earth metals, group 3 to group 12 is transition elements, and group 17 is halogen, lastly group 18 containing inert or noble gases. Firstly, we have group 1 from the predictables, which is alkali metals. In group 1, we have hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. So, as we can see, the hydrogen is the lightest because it's having atomic number of 1. The tables in this slide shows that atomic radius will be increased when the down group 1, also increase in reactivity, also increase in electron shell shielding the outer electron. But for the melting point and boiling point, it will decrease when down to the group 1 from lithium to francium. Also the tendency of density is increasing. Next we have group 17. Group 17 is called as halogen and are highly reactive. First we have fluorine. Fluorine is a pale yellow gas. Chlorine, green or yellow gas. Bromine is a orange or brown liquid, while iodine is grey or black solid or purple vapor. As we're going down to the group, the increase in molecular size will cause the attraction force between molecules to become stronger. The melting point and boiling point of halogen will increase because more heat energy is required to overcome the intermolecular force. The density of elements also increase with the increase in mass when going down to the group of 17. So in the table we can see that boiling point and melting point is increasing. Also the density also increased from chlorine to iodine. These are the usage of group 17 in daily life. Chlorine in bleach, bromine as a substance in fire extinguisher, and lastly, iodine as the disinfectant. Let us move on to the next group, which is group 18. Group 18, also known as noble gases, because they don't react with anything. In Group 18, we have helium, neon, argon, krypton, xenon, and radon. As we're going down to the Group 18, the size atomic radius increases due to the increase in the number of electron and electron-filled shells. Noble gases are chemically unreactive due to the valence shells that are fully filled with electrons. Noble gases have achieved stable duplet or octet electron arrangement, causing the atoms of noble gases to not donate, accept, nor share electrons with the atoms of other elements. The atoms of the noble gases exist as monoatoms. These are the uses of Group 18 in daily life. Helium is used to fill weather balloons, neon is used in advertising board lights, argon is used to fill in electric bulbs, krypton used in flashlight of cameras, xenon used in the lighthouse lamps, and radon used to treat cancer. The last group that we will talk about in this video is Group 3 to Group 12, which is transition elements. All transition elements are metals with the following properties. First, solids with shiny surfaces, very hard compared to metals in Group 1 and 2, very high density, have a very high melting points and boiling points. Several transition elements in periodic tables of element has their own special characteristics. First, transition elements function as a catalyst to increase the rate of reaction without underchanging chemical change at the end of the reaction. Second, transition elements form colored ion or compounds. Last one, transition elements have more than one oxidation number. That's all from me. Thank you.